Ever get that feeling? Like you're drowning in information, mountains of data everywhere, and you just want those key insights. Like someone could just point out what really matters.
Yeah, totally. Like sifting through a giant data dump, just hoping for that aha moment.
Well, that's kind of the mission today. We're diving deep into this whole idea of extracting information from data, turning it into something you can actually use.
It's like a crash course in data fluency. And to make things easier, we've been checking out these awesome YouTube videos from Sandy Chaka at Riverside Brookfield High School. Her stuff on the Code Curious channel is seriously clear and easy to get.
It is, right? Super helpful. And our goal today is pretty simple. We want to figure out how to go from raw data to actual knowledge. What are the bumps in the road? How do those patterns actually emerge?
Exactly. And by the end, hopefully you'll feel a bit more confident, like you can handle whatever data comes your way.
More clarity, more confidence, that's what we're after.
Yeah.
So first things first, before we can even analyze anything, we got to be able to work with the data itself.
Right, and that can be a bit of a hurdle at first. Depends on your own skills and what tools you're comfortable with. Are you a spreadsheet whiz? Just starting to dip your toes into coding?
Totally. Maybe you're all about those Excel formulas. Or maybe you're still figuring out how to filter data. There are so many tools out there. And where you are on that spectrum makes a difference.
It does, but here's the thing. Sanda makes this great point that no matter what size your data set is, there are going to be challenges right out of the gate. It's not just about those giant databases that can trip you up.
It's so true. A little spreadsheet can be just as messy as a massive one.
Exactly. And one of those fundamental challenges, big data or small data, is this thing called data cleaning. It's like prepping your ingredients before you cook. If your ingredients are a mess, your dish is going to be a disaster.
Oh man, tell me about it. I remember this one time I was trying to combine a few customer lists.
Oh yeah.
Nightmare, missing information everywhere, like no contact details for half the people. Then there were entries that made no sense. Email addresses with no @ symbol.
Ugh, the worst.
And don't even get me started on the duplicates. I swear I spent half the day just trying to sort it all out. But even simple things, like how people wrote their job titles, it was all over the place.
Inconsistency is a killer.
It really is.
And that's exactly what we mean by dirty data. Missing stuff, wrong entries, duplicates, and those inconsistencies, When the same info is written 5 different ways across different sources, think of a student database. Some kids are missing IDs, some grades say junior while others say 11, and maybe there's a GPA that's like way higher than it should be.
You can't really work with that, can you?
Not really, not until you clean it up.
Okay, so how do you actually do that?
Yeah.
It seems like you can easily make things worse if you're not careful.
Oh, absolutely. You can't just go deleting everything that looks a bit off. Sandy really stresses this. Every single change you make, you gotta document it. And the reason why you made it, think of it like an audit trail. You don't want to accidentally introduce errors or lose important info while you're cleaning.
Like performing surgery. Gotta be precise and keep track of every move.
Exactly. And it's just as important to do your research before you start making changes, like that crazy high GPA. Maybe it's not a mistake. Maybe the school has a weird weighting system for AP classes or something. You gotta check those things out first.
Yeah, that makes sense. Don't just assume it's wrong.
Right. And this whole idea of verification, it becomes even more crucial when you're using data from somewhere else. You have to think about how they cleaned the data. What decisions did they make about missing values or inconsistencies? Because those choices can really affect your conclusions down the line.
It's like you're inheriting their process, which might have its own set of problems. Okay, so another challenge that Sandy brings up is bias. Bias in data collection. And this seems like a really subtle but super important point.
Oh, it totally is. And Sandy breaks it down really well. There's intentional bias, which is when there's an agenda behind how the data is collected. And then there's unintentional bias, which can sneak in just because of the way the data is gathered.
Like with those online reviews, sometimes you wonder, do they ask specific people to leave good reviews?
That's intentional bias for sure. A company might only ask happy customers to leave reviews, which obviously gives you a skewed picture.
Yeah, you don't see the bad ones.
Right. Unintentional bias could be something like a survey that's only online. Sandy points out that this could leave out people who don't have reliable internet access, which would mean your data doesn't really reflect the whole population.
So the way you collect the data can actually introduce bias.
It can. And it's important to remember that just having more data doesn't automatically make it better.
Right, more of the wrong thing is still wrong.
Exactly. More biased data is just amplifying the problem.
Okay, let's shift gears a bit and talk about the sheer volume of data. I mean, obviously, having more data can give you more insights,
You can spot those subtle patterns.
but it can also be totally overwhelming. Just navigating a huge spreadsheet can be a challenge in itself.
It definitely can. And Sandy explains how handling those massive data sets often involves techniques like parallel processing. Basically, using multiple processors to work on different parts of the data at the same time. Like dividing a giant task among a bunch of workers so it gets done faster.
Breaking down the workload.
Yeah.
And that leads to this idea of scalability, right?
Exactly.
Can your systems and your skills handle not just the data you have now, but what you might have in the future?
Can you keep up as it grows? Can you efficiently process 10 times the amount of data? 100 times. That's something anyone working with data needs to consider.
Okay, so we've tackled the initial challenges, we've got the data ready to work with. Now let's get to the fun part, actually pulling out those insights and understanding what it all means.
Yes, we've prepped the ingredients, now what are we going to make? So when we talk about information in this context, what exactly are we looking for? Sandy defines it as a collection of facts and patterns extracted from data. It's moving beyond just the raw numbers. It's spotting those trends, connections, and insights. It's answering questions and understanding what's really going on. And data analysis is what helps us do that.
Okay, I'm with you so far. And one of the tools she talks about, which might sound a bit technical at first, but is actually super useful, is metadata. Data about data, what does that even mean?
Think of it as the hidden details that give context to your data. Sandy gives some really good examples. If you have a digital photo, the image itself is the data. But the metadata is all the extra info embedded in that file, like when it was taken, the location, camera settings, file format, all that.
It's like the credits at the end of a movie telling you who made it and all that behind-the-scenes stuff.
Exactly. And for a document, the text would be the data, but the metadata would be the author, title, date, file size, keywords, that kind of thing.
Right, the background information.
And this metadata is so useful for organizing and managing big chunks of data. Imagine trying to find a specific photo from years ago, but you have no idea when it was taken.
It'd be impossible.
Metadata makes it searchable. It makes the data way more usable. So next time you see a news article that throws out a statistic, think about the metadata. Where'd that number come from? How was it collected?
Yeah.
What are the limitations? Suddenly you have a much deeper understanding.
You're not just taking the number at face value. And Sandy also mentions how algorithms use metadata all the time, which I never really thought about before.
Oh yeah, it's everywhere. Think about how Spotify or Netflix recommend music and movies.
They seem to know me so well.
Right. They're not just looking at the content itself, they're analyzing metadata.
Right.
Genre, actors, release date, even what other people with similar tastes have liked. It's all driven by data about data. And as Sandy points out with that library example, metadata is crucial for categorizing and retrieving information efficiently.
Okay, so we're seeing how much you can learn from well-organized data. But there's this really important distinction that Sandy makes, and it's something that can easily lead you to the wrong conclusions if you're not careful. Correlation versus causation.
This is a big one. Just because two things happen at the same time they correlate doesn't mean that one is causing the other. It's so easy to jump to that conclusion.
Yeah, you see a pattern and think, I've solved it.
But it might not be that simple. And Sandy gives this perfect example about ice cream sales and sunglasses sales. You might see that when ice cream sales go up, sunglasses sales also go up. But it doesn't mean eating ice cream makes people want to buy sunglasses.
That'd be pretty weird.
Right, but the data might show that clear upward trend for both. The key takeaway here is that there's often another factor at play, a hidden cause driving both trends. In this case, it's warm, sunny weather. More people buy ice cream when it's hot, and more people buy sunglasses too. They're correlated, but one doesn't directly cause the other.
That's such a good example. It really shows how you can't just assume cause and effect from a correlation. You have to dig a little deeper.
You have to look for other explanations, and as Sandy points out, often a single data set isn't enough to figure out causation. Usually in more data, more research, and a good understanding of what's really going on to make that connection.
So let's wrap this up. For our listeners out there, we've walked through this whole process from raw data to meaningful insights. We talked about cleaning messy data, being aware of bias, and the challenges of working with different amounts of data.
We looked at how analyzing processed data can reveal information and patterns. We talked about metadata and how important it is for organizing and accessing that data. And we dove into the super important difference between correlation and causation.
And all of this isn't just for data scientists. This is about being informed in a world that's swimming in data. It helps you look at charts, statistics, and those data-driven arguments with a more critical eye.
It's about being able to ask the right questions.
Exactly. So here's something to think about. Now that you have a better understanding of all the work that goes into making sense of data, what are some of the first questions that pop into your head when you see someone using data to make a point? Think about the source, how they got that data, and whether their conclusions actually make sense.
It really changes how you see information, doesn't it?
It does. It gives you a whole new perspective.